User-defined events, also known as UDEs, are special structures that we use very often in Monospost. We use them when we want to activate an event or a function in the post processor, which cannot be activated by standard tools of the CAM system. Or in other words, we basically use them to activate a special mode, like activating a 90-degree angular head, or locking a linear axis in a 3-axis operation. UDEs are added inside CAM systems, and they must be added within or before the operations in which the special post-processing feature is desired to be enabled. To learn how to add and use UDEs in different CAM systems, look at the guides in the help. These guides explain how to add and use UDEs for each different CAM. After adding them inside CAMs, these UDEs are automatically written inside the apt.cl file. And when post-processing is started, Monospost reads these UDEs and activates the related events or functions inside the post-processor. Instead of adding UDEs inside CAMs, they can also be added using the user interface of Monospost. However, keep in mind that, instead of adding them inside Monospost UI, we mostly add UDEs inside CAMs. We prefer to add UDEs in Monospost UI, mostly on multi-channel Milturn post-processors, to select active turret or active spindle, and also to set the synchronization numbers of the channels. We use UDEs for many different purposes. For example, we use them to lock a linear axis, mostly y-axis, in 3-axis operations in Milturns and 5-axis milling machines. By doing so, we can perform the 3-axis milling operations by using the c-axis instead of y. We use them to position the rotary table at a particular angle in 3-axis operations on 5-axis milling machines and mill turns. We use them to activate 90-degree angular tools, or in other words angular heads. We use them to select the active turret and the spindle as main or sub in mill turns. And to activate many other special features inside Monospost post-processor. There are two types of them: standard predefined UDEs and custom UDEs. Here, you can see the current list of predefined UDEs in Monospost. You add them inside the CAM, and then Monospost reads them and automatically activates the related events inside the post processor. Keep in mind that these UDE expressions may change in each different CAM. To learn the UDE expression that can be used in your CAM, look at the CAM-specific UDE guides in the help. The second type is the custom UDEs, which are created by the end users inside Monospost developer. Note that you have to be a professional package user to define your own custom UDEs. As we always say, Monospost developer is the most flexible post-processor design tool, and custom UDEs are one of these flexible tools available in Monospost developer. Custom UDEs allow you to define your own expression inside the CAM system to activate a custom event inside the post processor. For example, here in this example, I already define activate probing expression inside my CAM program. This expression is then added inside the apt.cl file. And later inside Monospost developer, I can create an UDE to read and interpret this expression. I should give a name to my custom UDE. Later, I have to write the same expression here. However, note that I will use its sign instead of G54, because this is a parameter that can be changed by the end user. Instead of G54, the end user can define G55, G56, etc. And then I define which event this UDE will activate. Note that I cannot activate standard events of Monospost developer inside custom UDEs. I can only activate my own custom events. Therefore, I need to create my own custom event. When I give a name for the event here, this custom event will be automatically created. And I can also define the variables which will be used to store the values defined in that expression. As I've mentioned, G54 is the parameter of this UDE, and this parameter defines which work offset we will update after probing. We can store this information inside a string-type custom variable, which we will create for this purpose. I will first create this custom variable. Then I will select this variable inside this UDE. The information in this @sign will now be stored in measure-type variable. Lastly, I will add my custom event inside the top-level operation. Here, I can add the script, which I've already created to measure the work offset. Defining and using custom UDEs is an advanced topic. To learn more about how to define and use them, watch the related video.